Hi friends, for academic year 2021, for first BTech first semester, the Department of Mathematics offered the subject linear algebra and calculus. This subject is common to all branches. So, in this subject, we have 5 units. The first unit is matrix operations and solving system of linear equations. My name is Dr. B.R. Dudakunta, Department of Mathematics, JNT College of Engineering, Pulvendula. The structure of the first unit is first concept is rank of a matrix. The second concept is solving system of non-homogeneous and homogeneous linear equations. Third concept is eigenvalues and eigenvectors and their properties. Fourth concept is Cayley-Hamilton theorem. Fifth concept is diagonalization of a matrix. So now let us see one by one. The first one, before we going to discuss the rank of matrix, so we will cover some basic points, that is elementary row transformations. So elementary transformations, there are three types of elementary transformations. Transformations means operations. So these operations are applied on rows or columns or both. The first rule is First type is interchanging of any two rows or columns. Suppose we have taking R1 row and R2 row. Now we interchanging R2 is replaced by R1 and R1 is replaced by R2. Similarly, the columns C1 and C1 is replaced by C2 and C2 is replaced by C1. The second type is multiplication of each element of a row or column with a non-zero scalar. Here R1, Ri is a ith row that is multiplied by a non-zero scalar k and replaced in the same row. Similarly, Ci is the column, ith column that is multiplied by a non-zero scalar k. That result is replaced in the same column Ci. The third type is the addition of the elements of a row with the corresponding elements of the another row, which is multiplied by a non-zero scalar. So the third property is combination of first and second. Uh, Second and adding, addition and adding. So that is R ith row. Ith row is uh, interchanged by ith row plus k into jth row. Okay, the same way the column operations, ith column is replaced by ith column plus k into jth column. So the addition of the elements of a row with the corresponding elements of any other row, which is multiplied by a non-scalar. So these elementary transformations are used in rank of a matrix. So now we will go to the rank of a matrix. So interchange the first and second rows of a matrix. So this is the original matrix. So this is R1, R2, R3. So now replaced, R2 is replaced by R1 and R1 is replaced by R2. So minus 1, 2, 0, 3 and 0, 1, 3, 4 is replaced by second row. So 2 minus 3, 4, 1 is the same elements are laid in the third row. The second title is multiply the first row of the original matrix by 1 by 2. This is 2 minus 4, 6 minus 2. So 1 by 2 R1 means 2 by 2 1 minus 4 by 2 minus 2, 6 by 2 3 minus 2 by 2, that is minus 1. 1 3 minus 3 0, 5 minus 2 1 2. So this is the element in a row is multiplied by a non-zero scalar. Next, third one, add minus 2 times the first row of the original matrix to the third row. So the third row is 2 1 minus 5 2. So these elements are added to the first row. That row is multiplied by minus 2. The result becomes as shown in the new matrix as third one. Okay. Next, note that the elementary row operations is written beside the row that is changed. Next, zero row and non-zero row. If all the elements in a row of a matrix are zeros, then it is called a zero row. So in this matrix, we have non-zero rows and zero rows. So the zero row means all the elements are zeros. Non-zero row means at least one element is exist. At least one element is a non-zero. Then it is called a non-zero rows. That is explained through example. Next, echelon form of a matrix. A matrix is said to be A matrix is said to be echelon form of a matrix. A matrix is said to be in echelon form in echelon form, then it satisfies the following three properties. The first property is if if any zero rows exist, they should be always below the non-zero rows. Suppose in this D matrix, here this is the zero row, the remaining all non-zero rows. This is zero row, remaining all non-zero rows. So the zero row is always below the non-zero rows. The second point is the first non-zero entry in each non-zero row is equal to 1. Okay, the first non-zero entry. This is the non-zero row. This is the first non-zero entry is always 1. Next, the number of zeros before the first non-zero entry in each non-zero row is less than such a number of zeros in the next row. So we will see that point. So the number of zeros before the first non-zero entry, before the first non-zero entry is less than such a number of zeros in the next row. You observe that the number of zeros before the first non-zero entry is less than such number of zeros in the next row. Okay, here A, C, D are in echelon form, but B is not in echelon form because the zero row is always placed in the third row. The second row is replaced by third row is replaced by second row, and third row is replaced by second row, and second row is replaced by third row. Okay, so next reduce the following matrix to echelon form and hence find its rank. A equal to 5, 3, 14, 4, 0, 1, 2, 1, 1 minus 1, 2, 0. Now reducing this matrix into echelon form and find its rank. So to reduce the echelon form, to reduce the given matrix into echelon form, the first entry here 0, R1 is replaced by R3. This is okay. Next applying, we will make 5 and 3 as 0. For that, we have to multiplying R3 tends to R3 minus 5 into R1. So 5 into 5 into 1. So 5 into 1 means 5 minus 5 0. 3 minus of minus of 5. So that is 1. 3 minus 5. So that is 3 minus of minus 5 8. Next 14 minus 6, that is 4. 14 minus 10, 5 into 10. 14 minus 5 into 10, 10. 5 into 2, 10. That is 14 minus 10, 4. Next 4 minus 5 into 0. That is 4. Now we observe that in the first column, first two elements are zeros. The second column, 8 is not 0. That's why we make this element as 0. Then apply R3 tends to R3 minus 8 R2. We have A equal to 1 minus 1 2 0, 0 1 2 1, 0 0 minus 12 minus 4. So now which is in echelon form, the number of non-zero rows is 3, hence rank of A equal to 3. Next, reduce the following matrix into echelon form and hence find its rank. A equal to 1 2 3 0, B equal to 2 4 3 2, 3 2 1 3, 6 8 7 4. This is the 4 by 4 matrix. So rank is less than or equal to 4. 4 less than or equal to 4. Rank is less than or equal to 4. So that will be verified by solving this problem. Apply. Now we make 2 element as 0, 3 element as 0, 6 element 6 as 0. So for that I am applying the operations on R2. R2 means R2 tends to R2 minus 2 R1. R3 tends to R3 minus 3 R1. R4 tends to R4 minus 6 R1. So we get A 1 2 3 0, 0 0 minus 3 2, 0 minus 4 minus 83, 0 minus 4 minus 11, 5. So applying R2 tends to R3, we have now interchanging the rows. R2 tends to R3, 0 minus 4 minus 8 minus 3, 0 0 minus 3 2. Now we are applying R4, R4 tends to R4 minus R3. So we have This is in echelon form. Zero rows is always the below the non-zero rows. The number of zeros before the first non-zero entry in each non-zero is always less than 1. So that is the problem, that is the solution. Here, which is in echelon form, the rank of the matrix equal to the number of non-zero rows, that equal 3. So thank you, ma. So the next topic will be discussed in the next session.